we're going to compute these limits. When we see a limit to compute, the first thing we look at is say, could I directly evaluate this? This is a rational function, and as long as the denominator is not 0, I can just go ahead and put 2 in for y, and that's going to be the case here. So if I put 2 in here, the numerator is 4, and this is 4 plus 10 plus 6. So that's going to be 20. So our limit is 1/5 found by direct substitution. Now looking at the second one, I would have troubles if I tried to directly evaluate because I would be dividing by 0. So if direct evaluation fails, then we try some kind of algebraic manipulation to write an equivalent function that maybe we can directly evaluate. I see the denominator is the difference of squares. So I'm going to factor that, and the numerator also factors. It's going to be x and x minus 4 minus 2. So now I can actually write an equivalent expression with the difference being that x is not in the domain of the first one, but I can now directly evaluate this, and that will give me the limit. So 2 minus 4, negative 2, and 2 plus 2 is 4, and so our limit is negative 1/2. Now looking at this third one, I can't directly evaluate because I would be dividing by 0 and nothing factors, but whenever I see something involving a radical, I think of multiplying numerator and denominator by the conjugate, because that will give me an equivalent expression that maybe I can directly evaluate. So looking at this, I would have the limit as x approaches 1 of square root of x times square root of x is just x. Outers and inners cancel because they're conjugates. Last times last is minus 1. And then our denominator, we have our x minus 1 multiplied by the square root of x plus 1. I can reduce these factors, and now I can directly evaluate because I won't be dividing by 0, and I will get 1 over the square root of 1 is 1 plus 1 is 2, and there we have the limit.